Welcome guys! Today I'm going to be showing you how to find the remainder of division by any number for any number. So let's say you see a question like this, which asks us to find the last digit of 3 to the power of 87. A huge number. It's not like we're going to calculate this number and easily show the last digit. No, we're going to use something a bit different. So first let's think, what is a last digit? Consider dividing this number by 10. If that number is divisible by 10, meaning it gives an integer in return, then its last digit must be 0, right? Any number with a last digit of 0 will be divisible by 10. Now what if it's not divisible by 10? So it doesn't return an integer after dividing. Then its last digit will be something other than 10. But think about if you remove that last digit, if you subtract it from that number. Then you will again have a number which is divisible by 10, right? So you divide it and you're kind of in debt for that number you subtracted. And so if you divide by 10 and take the remainder of what you left out, then that remainder is going to be the last digit of that number. Hopefully this is simple and makes sense, so let's call our last digit n, and say that it is going to be equal to 3 to 87 mod 10. Now we have established that. Hopefully this makes sense. And we can write it in better notation, like this, 3 to 87 congruent to n mod 10. Where again, n is our last digit, what we have to find. Alright, so now the only question is to solve this congruence, and we would know our last digit. But how would we do that? Let me show you something very neat. Consider 3 squared, okay? That's just 9, right? And so it's congruent to 9 mod 10, in the mod 10. 9 mod 10 is also the same as minus 1 mod 10, right? Makes sense. If you add 1 to 9, you'll get 0 mod 10. If you add 1 to minus 1, you'll also get 0 mod 10. This is the same thing in the mod 10 world. Okay, that's very nice. We say that 3 squared is congruent to minus 1 mod 10. Okay, now let's rewrite our upper equation, congruence, into this form. 3 squared to the power of 43 times 3 again, congruent to n mod 10. Makes sense, right? What is 3 to the power of 87? We can just say it's 3 squared to the power of 43 times 3. You know, simple exponent rules. Okay, this is the same thing. But look at this. 3 squared in the mod 10 world is minus 1. So that's the same as writing minus 1 to the power of 43 times 3. Don't forget that. It's congruent to n mod 10. And minus 1 to the power of 43, it's to another power, so it's just minus 1. So then we can conclude that minus 3 is congruent to n mod 10. And still, we did nothing to n. N is still our last digit. And now we know that minus 3 is congruent to n mod 10. So we can say that the last digit, which has to be positive, we cannot have a negative digit, makes no sense, is going to be 7. Very nice, because 7 is congruent to minus 3 mod 10. And that is our answer. That is the units digit of 3 to the 87. So look, we just used the substitution and we gradually diminished our congruence into a state that we can calculate with our heads. How nice. Let's practice with another example here, where we have to find the last digit of an even bigger number, 2018 to the power of 2025. Okay, as said before, to find the last digit, we have to find the remainder of division by 10. Okay, so we just have to solve this congruence. 2018 to the 2025, congruent to n mod 10, where n is our last digit. Okay, great, and the goal is to diminish this congruence to a state where we can easily calculate it in our heads, because for now it's way too big. So what we can easily do right now is get rid of 2018 by stating that 2018 is congruent to 8, which is also congruent to -2 in mod 10, right? When divided by 10 you get 8, and 8 is the same as -2 on 10, just an even smaller number. So we can substitute this -2 into our congruence. And now it's already much smaller. -2 to 2025, congruent to, let me write it a bit more positively, the 2024 times -2, congruent to n mod 10. Great. And now we kind of just have to look at powers of 2 to keep going even further down. So what's a good power of 2 here we can use? I think 9 will be pretty good, right? Because 2025 is divisible by 9, and it gets us 225. So yeah, let's say, again, 2 to the 9 is 512, and it is congruent to 2 mod 10. And now we can substitute in this 2 to the 9 into our congruence to simplify it even more. And it's even better that 9 is just 2 in the mod 10 world. So I'll plug it back in. 2 to the 9 to the 224 times 2 to the 8 is -2 is congruent to n mod 10. That seems correct. This is just some arithmetic here. You can check it if you want, so that these powers all add up to our original statement. And now, look, because 2 to the 9 is the same as 2 in the mod 10 world, this 9 is here in the powers is essentially completely useless. We do not need it anymore. The same as 2. So now we have a congruence that 2 to the 224 times some other things is going to be congruent to our last digit, mod 10. Let's keep going even further by saying that 2 to the 9, the 24, times another to 8, times another to 8, and -2 is congruent to mod 10. Again, some more arithmetic. And because this 9 is not needed, we can get rid of it. Okay, so now we have 2 to the 24 times 2 to the 8 times 2 to the 8. Let's add these all up. This seems like 2 to the 16. And this plus 24 is going to be 2 to the 40 times -2 congruent to n mod 10. Okay, we're almost there, it seems like. Now I think a really good power here would be 5, actually. 2 to the 5 is congruent to 32. It's congruent to 2 mod 10. And look, 40 divides by 5 perfectly, so we don't need to multiply anything more like we've been doing here. Because that is 2 to the 5 to the 8. 5 times 8 is 40, times -2, which is the same as 2 to the 5, which is 2. So we don't even need the 5. It's 2 to the 8. And look, I think this we can already calculate pretty well, right? 2 to the 8 is 256 times another -2 is going to be -512. And that is congruent to n mod 10. That's it. And to simplify it even further, -512, that's the same if it's negative, so we go backwards a bit, and we get that -512 is congruent to 8 mod 10. Therefore, our last digit is 8. Very nice. Such techniques aren't only helpful for finding the last digit. Now we can in theory solve any congruence with any modulus. So as a final example, let's find the remainder of division of 10 to the power of 2021 by 13. Okay, so let's set up the congruence. It's going to be 10 to the 21 congruent to n mod 13, where n is the remainder we're trying to find. Great. So 10, let's again look at it and try to diminish this to a decent state. 10 is congruent to, seems like -3 mod 13, right? Because, or 7 mod 13. But I think -3 is the better choice here. minus 3 mod 13. Right? If you add 3 to 10, and if you add 3 to minus 3, you both get 0 mod 13. This should make sense. So we can substitute this into our congruence. Minus 3 to the 2021 congruent to n mod 13. Just like I did last time, I like to make it more positive. So 3 to the 2020 times minus 3, so it's like a minus, is congruent to n mod 13. Great. Now we have to think about powers of 3, which work pretty well in the mod 13 world. So this may take some creativity. I think I know the power. Let's see. Look at this. 3 to the power of 3, that is 27, right? And 27 mod 13 is 1, right? Because 26 is a multiple of 13. So 27 divided by 13, you get a remainder of 1. And there is nothing better in these congruences when you get a 1 mod 13. So now if we put in back 3 cubed into our congruence, then we can find something very nice and simple. Okay, 3 cubed times, doesn't even matter times what, it's going to, 2019 is the next thing divisible by 3. And it doesn't even matter either because it's going to be 1. So times something, and then times 3 again, because 2019 is the next thing divisible by 3. We have to add another 3 here, multiply. And don't forget our minus 3 from the beginning. Remember to n mod 13. And this 3 to the power 3 to the something, because I'm too lazy to divide, is just going to be 1. So this completely cancels out. We do not need it anymore because we say that 3 to the power 3 in the mod 13 world is 1. And could not be any better. We get that minus 9 is congruent to n mod 13. So that means n is equal to 4, or congruent to 4 mod 13. And that is our answer. N is 4. The remainder of division of 13 of 10 to the power of 2021 is 4. How nice. So that will be it for the video. Hope you learned something new from these techniques, and you can practice it on your own terms by picking 2 random numbers and some random modulus, and it's very fun. So yeah, that's it. Thank you for watching.